minus 3 minus ln y plus 4 express y in terms of x. Now this difference between logarithm can be written as in single form. You know the logarithm rule is log x minus log y, that will be equal to log x over y. Now we use this rule here. Now we can write it as x will be equal to ln 2y minus 3 over y plus 4. Now we convert this logarithm into exponent form. We use the rule here, x equal to log y base a. We can write it as a power x equal to y. Now we use the rule here also. Now the base of ln is e. Now therefore we can write it as e power x equal to 2y minus 3 over y plus 4. And we shift the y plus 4 from right to left side. Now we multiply ex by y plus 4. That is equal to 2y minus 3, and that is, we can write it as y into e power x plus 4 into e power x equal to 2y minus 3, and y into e power x minus 2y, and 4 power ex we shift from right to left side. Left to right side we get minus 3 minus 4 e power x, and y is taken as a common, we get ex minus 2 equal to minus 3 minus 4 e power x, and we can write it as y will be equal to minus into 4 e power x plus 3 over e power x minus 2. And this is the answer. Question 2, part A. On an Argand diagram, shade the region whose point represent complex number complex number z satisfying the inequalities minus 1 over 3 pi. Argument z minus 1 minus 2i is greater than minus pi over 3 less than 1 pi over 3, and real z less than 3. Now we have to shade the region against these inequalities. Firstly, we will draw the Argand plane. It consists of two axes. Along the x-axis is called real axis, and along the y-axis, the axis is called imaginary axis. Now we mention the real values here along the x-axis 1, 2, and 3. And same here is on the imaginary axis, we mention 1, 2, and 3. Now you see here, this inequality is argument z minus 1 minus 2 is less than pi over 3 and greater than minus pi over 3. Now firstly we write this inequality as, z minus 1 minus 2i. We write it as into equation form, that is pi over 3. Firstly, we write it. You see here, and this represents the half line. Now, in the half line, the argument z minus 1 plus 2i equal to pi over 3, we can write this equation, and this 1 plus 2i represents the complex number z0, and this number is the origin of this half line. Now we mention this, the coordinates of this complex number will be 1, 2. Now we mention here, this is the point 1, 2. You see here, now we draw a half line here. Here the argument z is minus 1 plus 2i equal to pi over 3. Now we take the angle pi over 3 and we draw a vector. This is the pi over 3 vector. And same here is negative pi over 3. We mentioned negative pi over 3 here. We have to mention the inequality. You see here the inequality is argument. This argument is greater than minus pi over 3. This is the positive pi over 3, and this shows the negative pi over 3 below the half line. Now we have to mention greater than minus pi over 3. Therefore, this shaded region upward side shows the greater than minus pi over 3. The next inequality is less than pi over 3. Now that is angle is pi over 3, we shade the region below this vector. Now this is the region from pi over 3. Now next is the real z is less than 3. It means we have to draw a line parallel to y-axis and passes through the point x real axis 3. Now we have to mention the inequality real z less than 3. It means the left side of the region shows this inequality. This is the real z less than 3. And this shaded region where the points represents the complex number satisfying the inequality. In the part B, calculate the least value of argument z for the points in the region. From A, give your answer in radians correct to 3 decimal place. Now you see here, this is the shaded region. The argument z value will be minimum. Now you see here, this point, at this point, we name it as A. We will draw the vector here. This is argument of this vector will be minimum. We name it as theta. Now to find theta, we see that this is a right angle triangle. Now we make here this right angle triangle. Now you see here this point O is the origin, B is the point of intersection of line and the real axis, and this point A is the point of the shaded region at which the argument z is minimum. Now we have to find the argument z of this point, and we suppose this is the argument of this point is theta. Now we have to find. Now you see here this point is 3, 0, B point, and A is 3, and the value of phi we have to find this value. We name it as B. Now to find the value of A, you see here two lines are intersecting at this point A. One is the line O dash A, and other is the line x equal to 3. Now we have to find the, we have to solve this equation simultaneously. Now the equation of line OA dash will be equal to y minus y equal to mx plus c. This is the equation of O dash A. Now you see here the gradient of this line O dash A is tan theta. Tan theta is minus pi over 3. That's value equal to minus 1.73. Now this equation becomes y minus 1.73x plus c. This equation of line passing through the point O dash, this line passing through O dash, therefore we put the value y is 2, x is 1, therefore the value of this, the value of c become 2 plus 1.73, and that value will be equal to 3.73, and the equation of this line y equal to minus 1.73x plus 3.73. Now we solve these two equations 1 and 2 simultaneously. Now we put the value x here, we get y equal to minus 1.73 into 3 plus 3.73. That value equal to minus 1.46. Therefore, that value b is minus 1.46. Therefore, the length of this line will be, you see here, the y coordinate of b is 0 and the y coordinate of a is minus 1.46. This length is minus 1.46. Now, OB length, you see here, this OB length will be equal to 3, that is 3, 0. From 0, 0 to 3, 0, the length will be 3. Now we argument z, the least argument, the least value of argument z will be equal to, argument z will be equal to theta, and theta will be equal to, tan theta will be equal to minus 1.46 over 3, and theta will be equal to tan inverse minus 1.46 over 3. And that is the answer is now that theta is minus 0.45, and this is the least value of argument z, minus 0.45. Question 3, the polynomial 2 into x power 4 plus ax cubed plus bx minus 1, where a and b are constant, is denoted by p of x when p of x is divided by x squared minus x plus 1, and the remainder is 3x plus 2. Find value of a and b. You see, now this polynomial is divided by x squared minus x plus 1. Therefore, we get the remainder by using the long division method. We write the polynomial 2x4 plus ax cubed plus bx minus 1. Now you see here, x squared term is not given. It means that term having the coefficient 0. Therefore, we can write it 0x squared. Now we divide this polynomial by this expression x squared minus x plus 1. The method is that here we divide 2x4 by x squared, we get 2x squared. Now with the 2x squared, we multiplied the whole expression. When we multiply 2x squared, we get 2x multiply x squared by 2x squared multiply x squared, we get 2x4, and minus x plus into 2x squared, that's equal to minus 2x cubed plus 1 multiply 2x squared, we get 2x squared. And next we subtract these expression. You see here this value will be cancelled. The sign of the below expression will be changed, and minus become plus, and that is become minus. Now you see here that value is a plus 2 into x cubed. Next is the 0 minus 2 is minus 2x squared plus bx minus 1. Now we divide a plus 2 into x cubed divided by x squared, we get a plus 2x. Now a plus 2x, we multiply this expression x squared minus x plus 1 by a plus 2x, we get a plus 2x cubed minus a plus 2 x squared plus a plus 2 into x. Now we subtract these values. The sign of the below expression will be changed. That value you see here, that is equal to minus 2 plus a plus 2 into x squared, and that expression plus b minus a minus 2 into x minus 1. Now you see here that value becomes ax squared plus b minus a plus a minus 2 into x minus 1. Now we divide ax squared divided by x squared, we get ax squared divided by x squared, we get a. Now we multiply this expression by a, we get ax squared minus ax plus a. Now we subtract these values. The sign of the below expression will be changed by plus and minus. That will be cancelled. And you see here, we can write it b minus a minus 2 plus a into x. And we write this minus 1 minus a. Now we can write it as, here, that is b, a will be cancelled. Now b minus 2ax plus minus 1 minus a. This is the remainder by long division. And you see here the remainder of in the question is given 3x plus 2. Therefore, we can write the remainder 3x plus 2 in the question given. Now we can write this remainder value b minus 2 into x plus minus 1 minus a. Now this remainder will be equal to the remainder after long division. Now you see here we compare the coefficient of x. Now b minus 2 will be equal to 3 and minus 1 minus a will be equal to 2. Therefore, b will be equal to 5 and you see here a will be equal to minus 3. And this is the answer. Now we go to the next question. Question 4, solve the equation 5z over 1 plus 2i minus z into z steric plus 30 plus 10i equal to 0. Give your answer in x plus I form where x and y are real numbers. Firstly, we find the value z into z steric. You know z is equal to, that is, we suppose that z equal to x plus yi and z steric will be equal to zx minus yi. This is the conjugate of z. Now we multiply z into z steric. Now you see here x plus yi into x minus yi. You see here we get a square minus b square identity, x square minus yi whole square. That value will be equal to x square minus y square I square. You know I square equal to minus 1, therefore we can write x square minus y square into minus 1. That value will be equal to x square plus y square. And same here is the 5 over 1 plus 2i. We convert this value into the rational form. Now this is the 5 over 1 plus 2i. Now we rationalize it. We multiply this value by its conjugate. We multiply and divide by this fraction by conjugate of this 1 minus 2i over 1 minus 2i. You see here we get 5 into 1 minus 2i over 1 square minus 2i square. Therefore, that value will be equal to 5 into 1 minus 2i over 1 minus 4. 2i square is minus 4. Therefore, we can write it as 5 1 minus 2i over 1 plus 4. That's equal to 5. Now 5 will be cancelled. Now we get 1 minus 2i. Now we substitute the value in this equation. You see here, this is the equation 1. We name it as. Now we put the value in this equation. We can write it 5 over 1 plus 2i. That's equal to 1 minus 2i into z minus z steric plus 30 plus 10i equal to 0. You know z value is equal to x plus yi and z steric is equal to x square plus y square plus 30 plus 10i equal to 0. Now we shift the value from right side to left side. That value becomes, now we must simplify it. You see here 1x plus 1yi minus 2xi minus plus minus 2y into yi. That becomes 2yi square. Now we shift this value from left to right side. That becomes x square plus y square and plus 30 become minus 30 minus 10i. And this is the minus 10i. Now you separate the real and imaginary value. You see here that is the imaginary value y minus 2x into I. And this value you see here x minus 2y I square value is minus 1. Therefore, we can write it as Now you see here this value is x squared plus y squared minus 30 minus 10i. Next is we can write it as x plus 2y plus y minus 2xi, that's equal to x squared plus y squared minus 30 plus minus 10i. Now we separate the real value. Now the real value, compare the real value. You see here x plus 2y will be equal to x squared plus y squared minus 30. And same here is y minus 2x equal to minus 10. Now we can write it y equal to 2x minus 10. Now we put the value of y in this equation. You see here, put value of y in above. Now we get x plus 2 into y is 2x minus 10 equal to x squared plus y square is 2x minus 10 whole square plus minus 30. Now we write it as minus 30. Now we can write it here is as you see here we can write x plus 2x minus 20, that's equal to x square. Now we use the identity a minus b whole square, that is a square, 2x square becomes 4x square minus 2 times of ab, that becomes 440 2 to the 4, 10, that's 40x, and that is minus plus 10 square is equal to 100 minus 30, and that value equal to, you see here, this is the x, sorry, x power 1. Now you see here that is equal to 5x square, that is 4x, this is 4x, 2 to the 4x, 5x and minus 40 minus 5. We shift the value from left to right side, that's become minus 45x and minus 20 here, that value plus 20, 120 minus 30, that is plus 90 equal to 0. Now we can write this value 5x squared minus 45x plus 90 equal to 0. We take the common 5, therefore that becomes x squared minus 9x plus 18. Now the factor is 6 3s are 18. We can write it as minus 6x minus 3x plus 18. Now we factorize this above expression. We get x minus 6 into x minus 3 equal to 0. Therefore, x minus 6 equal to 0 or x minus 3 equal to 0. Therefore, x equal to 6 and x equal to 3. Now, y equal to 2x minus 10, we get the value of y, put value of x here. Now you see here that value becomes 2, 6 are 12 minus 10. The value will be, y will be 2 against 6, and same here y equal to 2x minus 10 with when x is 3, 2 times 3 6 minus 10, that value is equal to minus 4. Therefore, we get the value 6 2 and here the 3 minus 4, this is the answer. Now question 5, the parametric equation of a curve are x equal to t e power 2t, y equal to t square plus t plus 3. Show that dy over dx equal to e power minus 2t. Now we can write it that dy over dx will be equal to dy over dt divided by dx over dt. Now firstly we find y equal to t square plus t plus 3. We differentiate y with respect to x, we get dy over dt will be equal to 2t plus 1. And same here is x equal to t into e power 2t. Now differentiate with respect to t. You see here that becomes dy over dt, and that value becomes 2t plus 1. And differentiate of t will be 1 and 3 will be 0. Now same here is differentiate of x with respect to t, the x equal to t into e power 2t, we get dx over dt, and we differentiate right hand side with also with respect to t. Now we use the product rule for differentiation. You see here u v d over d t, that will be equal to u dash into v plus v dash into u. The formula will be given in your formula sheet. From the formula sheet, you can check your formula. Now you see here the derivative of t will be 1. E to t is written as it is plus. Now you see here we write t as it is, and derivative of second function. The derivative of e power 2t will be equal to e to t into derivative of power is 2. Now we can write it 2. Now the formula of e power ax into d over dx, that's equal to a into e power ax. You can write this against this formula. Now we find the value dy over dx will be equal to dy over dt. dy over dt, you see here dy over dt is 2t plus 1 divided by, you see here that value is, we simplified, that value is e to t plus 2t e power 2t. We write it here e power 2t plus 2t into e power 2t. We can write it as 2t plus 1 over. Now we take the common e power 2t, we get 1 plus 2t. Therefore, both values are same. Therefore, it can be cancelled. Now we get 1 over e power 2t. That's answer is e power minus 2t. This is the answer. Here dy over dx equal to e power minus 2t. We have to prove this. Now we move the next part of this question. Now part B, hence show that the normal to the curve where t equal to minus 1 passes through the point 0, 3 minus 1 e power 4. Now firstly, we find the equation of normal to the curve. You know dy over dx equal to e power minus 2t. Therefore, at t equal to minus 1, that value dy over dx become e power minus 2 into minus 1. That's value equal to e power 2. Now this is the gradient of tangent. Now the gradient of normal will be equal to, we find the gradient of normal is the negative reciprocal. Now gradient of normal to the curve, negative reciprocal. This is the gradient of tangent. Now we can write it minus 1 over e power 2. Now you see here the point of this at t equal to 1. The parametric equation of the curve is x equal to t e power 2t and y equal to t square plus t plus 3. Now we put the value t equal to minus 1, that x will be equal to minus 1 into e power minus 2 into 1. And same here is y. Y will be equal to minus 1 square minus 1 plus 3. That value equal to 3, and that value equal to minus 1 over e square. Now we put the value in the equation of the normal. The equation of the normal is equal to y minus y1 equal to m dash, we name it as m dash into x minus x1. Now you see here y is written as it is, y1 is 3. M dash you see here is minus 1 over e square into x minus x1, you see here minus 1 over e square, and that value become Now we can write it as y minus 3 equal to minus 1 over e square x minus 1 over e power 4. Now we can write it as y equal to minus 1 over e square x plus 3 minus 1 over e4. That equation is compared with y equal to max plus c. You see here, this shows the gradient of the normal line, that is y equal to minus e 1 over e square, and it shows that the y-intercept. The y-intercept means the coordinate of the point will be 0, c, and this coordinate will be 0, 3 minus 1 e power 4. Now you see here, this is the point where the normal line passing through that point. You see here 0, 3 minus 1 over e power minus 4, and this shows that this equation of the normal is passing through this point. Now we can say that the above normal line passes through 0, 3 minus 1 e power 4 and having gradient minus 1 over e square. And this is the proof. Question 6, express 5 sine theta 12 cos theta in the form of r cos theta minus alpha. We can write it r cos theta minus alpha is written as r into, we use the formula cos alpha minus beta, that is cos alpha mean cos theta, cos alpha plus cos sine theta sine alpha. And we can write this r cos theta minus alpha is written as it is r cos theta cos alpha plus r sine theta sine alpha. That will be equal to this equation 5 sine theta plus 12 cos theta. Now we compare these two compare sine theta and then compare cos theta. You see here that value become r sine theta sine alpha will be equal to 5 sine theta, and same here is r cos theta cos alpha equal to 12 cos theta. Now we name this equation 1 and this equation 2. Now squaring and adding these equation. Squaring equation 1 and 2, then adding, we get r square. Firstly, we cancel these sine theta cancel, cos theta cancel. Now we can write it r square sine square alpha and r square cos square alpha. Now we add these values, we get, next is the right side, 5 square plus 12 square. Now we get 169, and that is equal to r square sine square alpha plus cos square alpha. Now we get r square will be r square into 1 equal to 169. You know, sine square alpha plus cos square alpha equal to 1. This is the identity of trigonometric ratio. Now we can write it, r will be equal to square root of 169, that's equal to 13. R will be equal to 13, and same the angle alpha we can find dividing the equation 1 by 2, dividing equation 1 by 2, we get r sine alpha over r cos alpha will be equal to 5 over 12. Now we can write it as tan alpha will be equal to 5 over 12. Now alpha will be equal to tan inverse 5 over 12. Now we take the value in radian, that value will be equal to, alpha will be equal to 0.394. This is the answer. 0.3947. Now in 3 decimal place, we write it 0.395. Now therefore, we can write this value here. R is 5, R is here to 13. We can write 13 into cos theta minus 0.395. That's equal to 5 sine theta, 5 sine theta plus 12 cos theta. And this is the expression in terms of R cos theta minus alpha. This is alpha, this is R. Now we move the next part of this question. Part B, and solve the equation 5 sine 2x plus 12 cos 2x equal to 6. Now you see here 5 sine theta plus 12 cos theta equal to, we can write it as 13 cos theta minus 0.395. Now from this relation, we can write it 5 sine, we replace theta by 2x plus 12 cos 2x, and that theta become cos, theta become 2x minus 0.395. Now therefore, we can, that left hand side become 13 cos 2x minus 0.395 equal to 6. Now we can write it as 2x minus 0.395 cos equal to 6 over 13. Now in acute angle value, the alpha will be equal to cos inverse 6 over 13. Now the alpha will be equal to 1.091. That's the alpha value. Now you see here, the range of the angle x is 0 to pi. Now the range you see here, x is 0 to pi. Now therefore, here is the 2x. Now the range will be equal to 2x will be equal to 2 pi. And that range 2x minus 0.395 to pi minus 0.395. And that is, therefore, the cos is positive in the first quadrant and the fourth quadrant. In the first quadrant, the alpha will be equal to theta. Now we can write it alpha equal to 2x minus 0.395. Now therefore 1.091 will be equal to 2x minus 0.395. Therefore 2x will be equal to 1.09 plus 0.395. X will be equal to, that value will be equal to 1.486, and divided by 2, that value will be equal to 0.743. Next, you see here the range of the angle between 0 to 2 pi minus 0.395. Therefore, that value will lie in the fourth quadrant, the positive value. The alpha will be equal to, you see here, this is the alpha. Now the theta will be equal to, you see here, if total angle theta, that will be equal to 360 minus 5. Now 360 minus alpha. Therefore, you can write it as 2x minus 0.395 equal to the angle in the radian form. We can write 2 pi minus alpha. Therefore, 2 pi minus alpha. Now we can write it as 2x minus 0.395 equal to 2 pi minus 1.091. Now we can write 2 pi minus 1.091 will be equal to 5.192, and that's 2x minus 0.395, and that's 2x will be equal to 5.192 plus 0.395, that value become 5.587, then x will be equal to 2.794, and this is the answer. Question 7, the diagram shows a circle with center O and radius R. The angle of minor arc AOB of the circle is x radian. The area of major arc, major sector of circle is 3 times the area of the shaded region. And now we have to prove the x equal to 3 over 4 sine x plus 1 over 2 pi. Now you see here the area of major sector will be equal to 1 over 2 r square theta. You see here r is the r. Now you see here theta will be the angle 2 pi minus x. This is the x radian. The major and segment major sector angle will be 2 pi minus x. We can write it as 2 pi minus x. The area of shaded region. The area of shaded region will be equal to area of sector OAB minus area of triangle AOB. Now area of sector, the formula is 1 over 2 r square theta. Area of triangle, we use the formula 1 over 2 r square sine theta. Now r is written as it is. Theta is x. R square, you see here r is written as it is. And sine theta we name sine x. Now here you see here the relation between the major and minor sector, the major and the shaded region, major sector and the shaded region. The area of major sector is 3 times the area of shaded region. Therefore, we can write it area of shaded region is 3 times area of major sector is 3 times. Now the area of major sector that is 3 times. This is 3 times the area of shaded region. Now we multiply 3 to equalize both areas. Now you multiply the area of shaded region. Now you write it as 3 into 1 over 2 r square x minus r square sine x. And that is equal to 2 pi 1 over 2 r square into 2 pi minus x. Area of major sector is this. Now we take the common 1 over 2 r square. That value becomes 3x minus 3 sine x equal to 1 over 2 r square into 2 pi minus x. Now 1 over 2 r square will be cancelled. Now we can write it as 3x minus 3 sine x equal to 2 pi minus x. X will be shifted from right to left side, that becomes 4x. And this 2 pi plus 3 sine x. Now x will be equal to 2 pi over 4 plus 3 over 4 sine x. And this can be written as pi over 2 plus 3 over 4 sine x. Now this is the expression we have to prove, x equal to 3 over 4 sine x plus 1 over 2 sine x. Part B, show by calculation that root of the equation in A lies between 2 and 2.5. Now this is the equation we already proved in previous part. In this equation, we have to prove that the root lie in between 2 and 2.5. To prove the root lie between these two values, firstly we make this equation f of x equal to 0. Therefore, we can write it as x minus pi over 2 minus 3 over 4 sine x equal to 0. Therefore, f of x will be equal to x minus pi over 2 minus 3 over 4 sine x. Now, firstly, we find the value f of 2. Now, f of 2 will be equal to 2 minus pi over 2 minus 3 over 4 sine 2. And same here is f of 2.5. Now, that value, we see that 2.5 minus pi over 2 minus 3 over 4 sine 2.5. Now we calculate it. This value is minus 0.25. And when we calculate this value, 2.5 minus pi over 2 minus 3 over 4 sine 2.5, that value will be equal to 0.48. Now you see here, f of 2 is less than 0 and f of 2.5 is greater than 0. When f of x change the sign, when the sign in f of x change, you see here f of x is negative and f of 2.5 is positive. This is the negative and this point f of x is positive. Now you can form the curve here at x equal to, this is 2 and that is minus 2.5, 0.25, and suppose this value is 0.48 at 2.5. Now we make it, and this curve shows that the function changes the sign, and when the function changes the sign, therefore the root lies in between these two values. Now we say that f of x signs change. It shows that roots lies between 2.2 to 2.5. Now the next part of this question. Part C, use an iterative formula based on the equation x equal to pi over 2 plus 3 over 4 sine x. Now the iterative formula, we write it as this is x n plus 1 and that value becomes pi over 2 plus 3 over 4 sine x n. Now we suppose that the x1 first value, we take the first value is between the root between lie 2 to 2.5. Now we take the mean value, that value will be equal to 2.25. Now the second value we can calculate here, the second value x2 will be equal to pi over 2 plus 3 over 4 sine x1. Now you can write it as pi over 2 plus 3 over 4 sine 2.25. That value will be equal to 2.15435. Now you can find the x3 values. You see here, well, you put in the calculator pi over 2 plus 3 over 4 sine 2.1453 and so on. These values you can get by using this rule. In the calculator, first step you will put value 2.25, the initial value, and then equal sign. In the second step, you put the value in the calculator pi over 2 plus 3 plus divided by 4, and same here is into sign. And then in place of x1, you press the answer icon. Now you press this button answer. After this, you will press equal sign. You will get this value, and you can get other values x4, x5, x6, and so on. I wrote these values here, and you see here the values of x9 and x10. The value is 2.8184, 2.184, 2.184. These value repeat itself. Where the value repeat, this will be the answer. This is the converging function at this value. Now, therefore, this will be the answer. You have to find that 4 decimal place value. Where the 4 decimal place value repeated, you see here this 2.184 repeated. Therefore, this is the answer. Question 8, the diagram shows the curve y equal to x cubed ln x for x is greater than 0 and its minimum point m. Find the exact coordinate of m. Now this is the, you see here, this is the turning point of the curve. The turning points of the curve, the gradient of the curve will be 0 at this point. The gradient of this curve we find, the gradient we can find by taking the derivative dy over dx. Therefore, you see here, this is the function in product form. Therefore, we write its u into v formula d over dx. In this formula, u dash v plus v dash u, we can write it here. The derivative of first function, we can write 3x square into ln x is written as it is, plus x cube is written as it is, and the derivative of ln x is 1 over x. Now we can write it as 3x square into ln x plus x will be cancelled the power, x cube become x square. Now we take the common x square into 3 ln x plus 1. Gradient of tangent at m where the turning points, the grade will be 0. Therefore, we can write it dy by dx is 0. And therefore, x square will be 0. And 3 ln x plus 1 equal to 0. Now we can write it as x will be 0 and ln x equal to minus 1 over 3. Therefore, we can write it as e power minus 1 over 3 equal to x. Part B, find the exact area of the shaded region bounded by the curve, the x-axis and the line x equal to 1 over 2. You see here, this is the line x equal to 1 over 2. This line is the x-axis which intersects the curve at this point. Firstly, we have to find the point of intersection between the curve and the x-axis. We can find this value. You see here the y equal to x cube ln x. Now we put y equal to 0. Now that value x cube ln x. Then you see here x cube will be equal to 0 or ln x equal to 0. Now you can write x will be equal to 0 and that can be written as e power 0 equal to x. It means x equal to e power 0 mean 1. Now therefore that point will be 1, 0. Now we have to find the area of the shaded region bounded by this x-axis and the line x equal to 1. Therefore, we will integrate to find the area of the shaded region. Now we integrate y into dx and we will take the limits between, you see here that is 1 over 2 and 1. We write it as 1 over 2 and 1 that will be equal to area of this shaded region. Now you see here y is x cube ln x cube ln x dx into 1 over 2, 1. Now to integrate this product expression, you can use the formula to integrate this product value. Now this formula is given in your formula sheet. That is the formula. Here is you have to select first term and then dv over dx is the second term. Now first term is considered as u and second term is considered as dv over dx. Now we can select the first term according to this rule. In this rule, the logarithm is taken as a first term and algebraic is in the preference is second. Trigonometric is the third and exponent is the fourth. You can use this word late and you can remember the preferences of the selecting first and second term. You see here the logarithm is taken as a first term and then the second term you will take as a x cube. Now you see here in the formula the u dv over dx equal to uv minus integrate v du over dx. Now therefore we have to find du over dx. Now the du over dx will be equal to 1 over x. Now you take the derivative, that's value equal to 1 over x and after integrating dv over dx, you can find the value of, you can find v. You see here v. Now we integrate it. Now that value become v will be equal to x4 over 4. And same here. Now we put the value in the formula. Formula is, you see here, u into dv over dx into dx will be equal to uv minus integration of v into du over dx into dx. Now we put the value here. U is ln x. V is x power 4 over 4. And you see here, v is already x power 4 over 4. And du over dx is 1 over x dx. Now we put the limits here. That is 1 over 2 and 1. We can write it as 1 x power 4 over 4 ln x. Now we apply the limits also here. 1 over 2 into 1. And same here is 1 over 2 into 1. And that is x power 4 ln x. And the limits is 1 over 2 to 1 minus, that is equal to x cube over 4. We can write it as minus 1 over 4 x cube dx. Now that is 1 over 2 into 1. Now we can write it as ln x power 4 over 4 ln x minus 1 over 4. That integration of x cube will be x4 over 4. Now we apply the limits as a whole. Now we apply here 1 over 2 into 1. Now put the limits in this integral in this expression after integration. You see here, firstly we put 1, that's value equal to 1 over 4 into ln 1 minus 1 over 4 into 1 over 4. Next is the minus. Now we put the value 1 over 2, that is 1 over 2. Now you see here, x power 4 is 1 over 2 power 4 in over 4 ln 1 over 2 minus 1 over 4 into 1 over 2 power 4 over 4. Now we can write it as ln 1 is 0. Now minus 1 over 4, 1 over 4 is minus 1 over 16 minus 1 over 64 into ln 1 over 2 minus, that is 1 over 64 1 over 4 into 1 over 64. Now we can write this value as minus 1 over 16. Now you see here, minus minus plus 1 over 256 minus 1 over 64 ln 1 over 2, and you can write it as, now you can write it as here minus 16 plus 1 and minus 1 over 64. That is log ln 1 over 2. You can write it ln 2 power minus 1. Now that value become minus 15 over 256 and minus 1, the power of 2 minus 1 is taken as a coefficient, that become plus 1 plus 1 minus, you can write it minus 1 into minus 1, 1 over 64 ln 2. Therefore, the answer will be, exact value will be of the shaded region, area of shaded region, it will be equal to minus 15 over 64 plus 1 over 64 ln2. This is the answer. Question 9, the variable x and y satisfy the differential equation. This dy over dx equal to e power 3y sine square 2x, and solve the differential equation, find the value of y. Now you see here the differential equation is dy over dx equal to e power 3y sine 2x. Now we can write it as, we separate the variable y and x. Now you see here that variable e power 3y shift from right to left side, that becomes dy over e power 3y. And next is you can write it sine, sine square 2x. Now we can write it sine square 2x into dx. Now we shift the e power 3y from denominator to numerator, that's become e power minus 3y into dy, and that sine square 2x is written as it is. Now we integrate on both sides. Now therefore after integration both sides, that equation becomes, now you see here e power minus 3y integration, that's the integration of eax px. You know this is the integration will be equal to eax over a. Now we write it as here e power minus 3y over minus 3, and that's equal to sine square 2x dx. We cannot integrate directly. We convert this sine square 2x in this form. You see here the sine 2 sine square x equal to 1 minus cos 2x. Now we can write it as sine square 2x will be equal to 1 minus cos 4x. You see here, this is the angle when the x, this angle become 2 times of this angle. Therefore, when you write sine square 2x, this angle become 1 minus cos 4x. Therefore, we can write it as square 2x is equal to, will be equal to 1 over 2 minus 1 over 2 cos 4x. Now we write it as 1 over 2 minus 1 over 2 cos 4x dx. Now we integrate this. You see here that's value become 1 over 2 x minus 1 over 2 is written as it is. The integration of cos 4x is sine 4x over 4. Now plus c, and that is minus 1 over 3 e power 3y. Now this is the equation of the equation after, this is the solution of the differential equation. Now we find the c when x equal to 0 and y equal to 0. We can write it as minus 1 over 3 e power 0 equal to 1 over 2 into 0 minus 1 over 2 into sine 0 over 4 plus c. You see here that equation become minus c will be equal to 1 over 3 e power 0, and that is equal to minus 1 over 3 cos e power 0 is 1, and all other values will be 0, and sine 0 is 0, and that is 0. Therefore 0 minus 0 is 0. Therefore c will be equal to minus 1 over 3. Now this equation can be written as minus 1 over 3 e power 3y equal to 1 over 2x, 1 over 2x minus 1 over 8 sine 4x minus 1 over 3. Now you can write, this is the solution of differential equation. Now we have to find the value of y when x equal to 1 over 2. Now we put the value here. Now you see here minus 1 over 3 e power 3y is written as it is. 1 over 2 into x is 1 over 2. That's minus 1 over 8 into sine 4 into 1 over 2 minus 3, 1 over 3. Now we can write it as 1 over 4 minus 1 over 3. That is equal to minus 1 over 12. Now you see here. And same is minus 1 over 8 sine 2. Now next is you multiply by minus 3, the value become 1 over e power 3y will be equal to, you multiply it by minus 3 both sides, you get 1 over 12 minus 1 over 8 sine 2, 1 over e power 3y will be equal to minus 1 over plus 1 over 4 plus 3 over 8 sine 2, and you can write it as 2 minus 3 sine 2 1 over e power 3y. Now you can write it as e power 3y equal to 8 over 2 minus 3. Now this is the minus minus plus plus 3 into sine 2. Now e power 3y equal to 8 over sine 2. Now you can write it as in logarithm form. Then you take the logarithm on both sides. That value will be equal to 3y equal to ln 8 over 2 plus 3 into sine 2, and y will be equal to 1 over 3 ln 8 over 2 plus 3 into sine 2. Now we calculate the value. Now that's equal to 0.175, and this is the value of y against x equal to 1 over 2. Question 10, with respect to the origin O to the points A, B, C, D, a position vector OA is equal to 3 minus 1, 2, OB 1, 2, minus 3, OC 1, minus 2, 5, and OD 5, minus 6, 11. Find the obtuse angle between vector OA and OB. Now we will use the formula to find the angle, that's equal to A dot B equal to A1, B1, A2, B2, A3, B3 equal to AB cos theta. And this is the formula given in your formula sheet. Now you see here, firstly we find OA dot OB. Now OA dot OB will be equal to 3 minus 1, 2 dot 1, 2 minus 3. That will be equal to A1, A2, 3 multiplied by 1 plus minus 1 multiplied by 2 plus 2 multiplied by minus 3. Now that answer will be equal to 3 minus 2 minus 6, and that will be equal to minus 5. And next is we have to find OA magnitude. Now you see here, firstly you have to find OA magnitude will be equal to x square plus y square plus z square. That will be equal to 3 square plus minus 1 square plus 2 square square root, and that value will be equal to 9 plus 1 plus 4. That's equal to 14, square root of 14. Now next is you have to find OB magnitudes. That value will be equal to 1 square plus 2 square plus minus 3 square. Now you can calculate, that's also equal to square root of 14. Now the angle between OA and OB, we can write it's OA dot OB equal to OA magnitude into OB magnitude into cos theta. We name is the angle theta. Now OA dot OB you see here is minus 5, OA is square root of 14. OB is also square root of 14. And that's cos theta. Now we can write it as cos theta will be equal to minus 5 over square root 14 become 14. Now therefore theta will be equal to cos inverse 5 over 14. Now we take the acute angle value, then alpha will be equal to cos inverse 5 over 14 equal to 69.1. But we have to find the obtuse value, and that is equal to cos 180. Now we write it as theta will be equal to 180 minus alpha. This is the obtuse angle value. Therefore, that value will be equal to 180 minus 69.1, and that is equal to 110.9 degree. Line passing through the points A and B. B part, find the equation for the line L. Now the equation of the line which passing through 2 points, that's equation, general equation will be equal to R equal to A plus lambda B minus A. Now you can write it as B minus A. B minus A, that's OA, we can write it as OA equal to A. Now you see here, this is the A, OA, and this vector is OB, is already given above. Now we can write it as OA will be equal to 3, 1 minus 1, 2, and lambda is written as it is. Now B minus A, you can write it as B is 1, 2 minus 3, 1, 2 minus 3, minus the vector of A is 3 minus 1, and that's 2, and we can write it as, now this value R will be X, Y, and Z. Now you can write it as 3 minus 1, 2 plus lambda minus 1 minus 2 minus 2, 2 minus 1 plus 1, 2, that's become 3, and this is minus 5, and that is X, Y, and Z. This is the equation of a line which passing through the points A and B. Question 10, with respect to the origin, the points A, B, C, D have the position vector OA, OB, OC, and OD. Now find the position vector of the point of intersection of the line L and the line passing through C and D. Firstly, we find the equation of line which passing through C and D. We name it as M line. Now you see here, we can write this equation, general form of the equation, R equal to OC. This is the point which passing through the line. Now mu is the constant, we take mu into the 2 points form, we write it's OD minus OC. Now this is the general equation of the vector. Now OD minus OC will be equal to 5 minus 1 minus 6 minus 2 become plus 2, 11 minus 5, that value become 4 minus 4 and 6. Therefore, that equation become X, Y, Z equal to OC is 1 minus 2, 5 plus mu OD minus OC 4 minus 4, 6. And this is the equation of line M. We can write it in the parametric form. X will be equal to 1 plus 4 mu, and Y will be equal to minus 2 minus 4 mu, and Z will be equal to, you see here, 5 plus 6 mu. You see here this equation, line L, and this equation is X, Y, Z will be equal to 3 minus 1, 2, and plus minus 2, 3, minus 5 lambda. Now the parametric form will be equal to X equal to 3 minus 2 lambda, and y will be equal to minus 1 plus 3 lambda, and z will be equal to 2 minus 5 lambda. Now we compare the x values. You see here that value become 1 plus 4 mu will be equal to 3 minus 2 lambda. And same here is next is minus 2 minus 4 mu will be equal to minus 1 plus 3 lambda. And next is the z. We compare the z equation 5 plus 6 mu will be equal to 2 minus 5 lambda. Now we can write this equation 4 mu plus 2 lambda will be equal to 3 minus 1 is 2. And next equation you can write it as minus 4 mu minus 3 lambda will be equal to minus 1 plus 2 is 1. Now we simplify these two equations 1 and 2. We add these equations. You see here that will be cancelled. Now minus 1 lambda will be equal to 3 and lambda equal to minus 3. Now we put the value in equation 1. Put value of lambda in 1. We get 4 mu plus 2 into lambda is minus 3 equal to 2. We can write it 4 mu equal to 2 plus 6. 2 minus 6 become right side. When you shift left to right side, that become plus 6. Now that's equal to 8. Now mu will be equal to 2. Now we substitute the value of mu and lambda in this equation. This equation third. Now if this satisfies the equation, we will say that the line L and M intersect to each other. Now you see here, now 5 plus, we can write it 5 plus 6 into 2, and here is lambda is 3. We can write 5 into lambda is minus 3. We can put value of mu and lambda. Now you see here that is 17. This is also 17. Therefore, it satisfies the equation. We say that the line L and the line passing through C and D intersect each other. And the point of intersection we can find, put the value in any of these equations. So we can find the value of x. 1 plus 4 lambda, 4 mu. Now we can write 1 plus 4 into mu is 2. Therefore, that value is 4 to the 8, 9. And same here is y will be equal to minus 2 minus 4 mu. Now we can write minus 2 minus 4 into 2. That value will be equal to minus 10. And same here is z will be equal to 5 plus 6 mu, and 5 plus 6 into 2. That value will be equal to 17. And the position vector of point of intersection equal to 9i minus 10j plus 17k. Question 11, let f of x equal to 5x square plus x plus 11 over 4 plus x square into 1 plus x. Express in partial fraction. In the partial fraction, we convert the single fraction into more than two fractions. You see here this fraction in the denominator, there are two expressions. One is linear and other is the quadratic. Now for the linear fraction, the numerator we name it as a, and for the quadratic fraction bx plus c. Now we find the a and b and c value. Now you see here, firstly we multiply this equation, this we name it as equation 1, by denominator 4 plus x square into 1 plus x. We multiplying equation 1 by 4 plus x square into 1 plus x. After multiplying, the left side becomes 5x square plus x plus 11, and right hand side become a into 4 plus x square and bx plus c into 1 plus x. Now for a, we substitute the value x equal to minus 1 in this equation. We get by 5 into minus 1 square minus 1 plus 11, a into 4 minus 1 whole square, that become 1. And you see here 1 minus 1 is 0, you can write it. And therefore 5a, and that is 5 minus 1 plus 11. And therefore 5a will be equal to 15 and a will be equal to 3. Now to find the other values, we substitute the real values in this equation, or we suppose we put the value x equal to 0. Now the substitute x equal to 0, we get 5 into 0, 0 plus 0 plus 11 into a into 4 plus 0 plus b into 0 plus c plus into 1 plus 0. Therefore, we get 11, and that is 4a plus c into 1. And we substitute the value of a is 3, 4 times 3, 11 plus c. Therefore, c will be equal to 11 minus 12 equal to minus 1. Now we find the next value. For the next value c, we substitute x equal to 1 in this equation. This is the equation, we name it as 2. Now when x equal to 1, this equation becomes 5 into 1 square plus 1 plus 11 equal to a into 4 plus 1 square is 1 plus b into 1 plus c into 1 plus 1. Now this value is substituted in this equation 2. Now that value become 5 plus 12 equal to 5a plus b plus c. 1 plus 1 is 2. Now 2b plus 2c. Now a is equal to, you see here is 3. Now 5 times 3 plus 2 into b plus 2 into minus 1, c is minus 1. Now you can write it as 15 minus 2, that's equal to 13 plus 2b equal to 17. You can write it as 17 minus 13 is 4 equal to 2b, then the b will be equal to 2. Now b is 2. Now we substitute the value in this equation 1. Therefore, that equation 1 becomes value a, b, c in equation 1. The equation 1 becomes a is, you see here, 1 over 1 plus a is 3, 3 over 1 plus x. You see here b is 2. Now 2x plus c is 1 minus 1 over 4 plus x square. And this is the partial fraction of this. expression x square plus x plus 11 over 4 plus x square into 1 plus x. And this is the answer. Now part B, and show that 0 to 2 f of x dx equal to ln 54 minus pi over 8. You know f of x equal to 3 over x plus 1 minus 2x minus 1 over x square plus 4. In the part A, we already the fraction resolved into partial fraction. This is the partial fraction form of this function. Now we write it as f of x is equal to 3 over x plus 1 minus 2x minus 1 plus 2x minus 1 over x square plus 4. Now we integrate this 0 to 2 dx. Now we can write it as 0 to 2 3 over x plus 1 dx plus 0 to 2, we can write it as 2x over x square plus 4 minus 1 over x square plus 4 dx 0 to 2. Now the integration of 3 over x plus 1 will be, that's equal to 3 is written as it is, 1 over x plus 1. Integration of this will be equal to log x plus 1 plus 2x over x square plus 4. The integration of this is the formula of f dash of x over f of x. Integration, that's value will be equal to ln x square ln f of x. The formula is that equal to ln f of x. Now we write it as ln x square plus 4. Next you see here 0 to 1 over x square plus 4. That's the integration of this. Now you know the formula of x square plus a square integration. This is equal to 1 over a into tan inverse x over a. This is the formula. We substitute here. Now 1 over a is 2 square. We can write it as 2 square. Now 1 over a is 1 over 2 in tan inverse x over 2. Now we apply the limit 0 to 2. Now we put the value here. In this here, we can write it as 3 into ln 1. The value is, you see here, is 2. ln 2 plus 1 is 3 plus ln 2 square plus 4. That's become 8 minus 1 over 2. Tan inverse 2 over 2, 1 minus, we put the value 0, that's equal to 3 into ln 1 minus plus ln 0 plus 4 is 4 minus 1 over 2 tan inverse 0. Now you see here that is 3 ln 3 is written as it is plus ln 8 minus tan inverse 1 is pi over 4, 1 over 2 into pi over 4, and minus 3 ln 1 is 0, ln 0 is 1, now minus 3 0, minus ln 4, minus tan inverse 0 is 0. Now we can write it as 3 into, that's equal to 3 ln power 3 plus ln 8 minus ln 4 minus pi over 8. Now we can write it ln. We here apply the logarithm rule. Now the 3 ln 3 power 3 is 27, and plus ln 8, these two values will be multiplied, and minus ln 4, that value will be divided, 4 will be divided this value, 4 and the This value will be divided by 4. Now we get ln 27, ln 54 minus 5/8. And this is the proof. We have to show that the f of x dx equal to ln 54 minus 5/8, and this is the answer.